Hello everyone, today we're going to begin solving the mock test paper for CET for the subject physics. So let's take a look at the first question. The first question says that a compound microscope consists of an objective of focal length 2 centimeters and an eyepiece of focal length 6 centimeters separated by a distance of 15 centimeters. At what distance from the objective should an object be placed so that the final image is formed at the least distance of distinct vision? The options given to us are minus 1.1 centimeter, minus 2.1 centimeter, minus 1.5 centimeter and minus 2.5 centimeter, and the answer to this question turns out to be minus 2.5 centimeter. So let's quickly take a look at why is the answer minus 2.5 centimeter. So the first thing we need to do is remember that a compound microscope consists of two lenses. One of them is the eyepiece and the other is the objective. Now we have been told in this sum that the focal length of the objective is 2 centimeter and that of the eyepiece is 6 centimeter. The next thing we want to recall is how does a compound microscope work? Well, in a compound microscope we place the object on one side of the objective and then we draw its image, and we do that by drawing the appropriate rays. Now let's draw the appropriate rays. We know that there are two types of rays, one which will go through the optical center and the other one which is parallel to the optical axis and then passes through the focals of the lens. So you see we have drawn these two types of rays, and where they meet is the location of my image. So I hope you have recalled how we have drawn this ray diagram for the first lens, that is for the objective. Now let's write down some technical terms. The distance between the object of the objective and the optical center is what we call as the object distance. That is, we denote it by the letter U. However, I have also kept a subscript O because it's the object distance for the objective. Similarly, the distance from the optical center to the image is what we call as the image distance, but since we are talking about the objective, I have a subscript O. So I have U naught and V naught as the object distance and the image distance in case of the objective. The next thing I want to do is continue to form the image. Now remember, in a compound microscope, the image formed by the objective is what is used as an object for the eyepiece. That means this image that we have formed here is going to act like an object for our eyepiece. And therefore, this distance is what we will call as the object distance for the eyepiece, because, as I repeat again, this image is going to act as an object for the eyepiece, and therefore the distance from this image to the optical center of the eyepiece is what I am going to call as the object distance U, and I have given it a subscript E because it stands for the eyepiece. Finally, what I will do is recall that they have told us the distance between both the lenses is 15 centimeter, which is from one optical center to the other. And now if you take a look at the diagram very quickly, you will see that the simple relation can be formed. That is, I can say V naught plus UE is equal to 15 centimeter. That is the image distance for the objective plus the object distance for the eyepiece together come out to be 15 centimeter, and this relation will come out to be very important. So remember, L is equal to V naught plus UE is equal to 15 centimeter. Finally, I will finish my ray diagram by drawing the appropriate rays even for the second lens, and I will get the location of the image for the total compound microscope. Now, what is the distance of this final image from the eyepiece? Technically, we will call it the image distance for the eyepiece, and therefore we will denote it as VE, and we have been told what VE is. We'll see that in a moment. But for now, let's take whatever we know from this diagram. We know the focal length, we know the relationship, and we want to see what is the image distance in case of an eyepiece. So I'm going to gather all this data and keep it in my given section. So now if I look at the question and I see that the last statement says that the final image is formed at the least distance of distinct vision, and therefore VE comes out to be minus 25 centimeter, because you know the least distance of distinct vision is 25 centimeter. The minus is given because the final image comes to the left of the eyepiece. Now once I have all this information, I can actually begin solving the sum. What is asked in the sum is to find what would be the object distance for the objective. That is, initially where must I keep the object in such a way that the final image must come out to be at the least distance of distinct vision. So I start solving. What I do is I write down the formula for the eyepiece that we already know. That is 1 upon VE minus 1 upon UE is equal to 1 upon FE. And what we actually want to find out of this is the object distance for the eyepiece, and therefore I take 1 upon UE to one side and I write 1 upon UE is equal to 1 upon VE minus 1 upon FE. Now we can put the values. We already know that VE is minus 25. We know that FE is 6 centimeter, and if I solve this, I get UE is equal to minus 150 upon 31 centimeters. That is, I have got the object distance in case of the eyepiece. Now, recall that this minus sign is only an indication that according to sign convention, your object must be on the left side of the eyepiece, and therefore, in case of distances, I don't need this minus sign. And if I just want to ask what is the distance, then I don't have to say minus because distance is never negative. So, the distance from the eyepiece of the object is 150 upon 31 centimeter only. And why am I asking you what is the distance? Because the total distance, that is L, is equal to V naught plus UE, and that is 15 centimeter. Now, we already know what UE is, and therefore, this can help us to find what is V naught. So, V naught will come out to be L minus UE, where L is nothing but 15 and UE is what we just found, and therefore, I have 15 minus 150 upon 31. So, V naught comes out to be 315 upon 31 centimeters. Now, what is V naught? It is the image distance in case of the objective. Now, finally, I have V naught, that is the image distance in case of the objective, and I will do what I have to do last, that is I will use the formula in case of the objective. That is the same formula as I used before, but now I am going to write it in terms of the objective. So, I have 1 upon V naught minus 1 upon U naught is equal to 1 upon F naught, but I already have the value for V naught. I have been told what is F naught and I can find U naught. So, quickly let's substitute the values. 1 upon U naught is equal to 1 upon V naught minus 1 upon F naught. V naught is nothing but 315 upon 31 as we have already been told before. We have calculated this before. Minus 1 upon F naught. F naught is given to us as 2 centimeters as given in the sum. And if I finish this, I will calculate the value for U naught, and that will come out to be minus 2.49 centimeters, which I will approximate to minus 2.5 centimeter. So, U naught is what we wanted, that is the distance at which the object should be initially placed so that the final image must come out to be at the distance of distinct vision. So, we have the answer, that is minus 2.5 centimeter, and this is the answer of the first question. Thank you for watching.